Hey guys, Mr. Bowman here. Today's learning objective is in pink and we are learning to introduce kinematics, so underline that, and we're going to link that to the calculus that we've been learning. So the first thing we need to get into, well, what exactly is kinematics? If we don't know that, we'll struggle to apply it to our calculus. So kinematics, that is from physics. So if you do take physics, you may be aware of this already. And it is to do with the motion of objects. And there are three concepts that are very, very relevant to kinematics that will play a big part in our topic. So the first is this idea of displacement, and it'll very commonly be the distance or how far something has traveled from a given point and in a given direction. The second one that's going to be relevant is the velocity. And that is the rate of change of the displacement. And I'll explain what that means as well. And finally, the last one, that's to do with the acceleration. And like the velocity, it's about the rate of change. Rate of change. But instead of it being about the displacement, it is about the velocity as well. So that's what we've got. Let's quickly explain what that means. So in terms of placement, it's typically something to do with the meters or some kind of distance that you've traveled. The velocity is how many meters you travel per second, typically. And the acceleration, well, that's how many meters you travel for every second squared. So those are the units that they all relate to. And all three of these have a direct relationship with each other. So I'm going to write them on the board, and we'll actually change pen colors for this. So the displacement or the distance is typically on the top of the chain. And then below that we have velocity, and below that we have acceleration. And if you're given an equation to do with the displacement, you can get to an equation for the velocity by differentiating. And if we differentiate once more, that will give you the equation for acceleration. Just like in our calculus methods that we've learned, you can go backwards, and the opposite of differentiation is integration. And you can go from acceleration to velocity by integrating. But just a reminder, you will have that annoying plus c. And just again, you can go from velocity back to displacement also via integration. But once again, you're going to have that annoying plus c. So for these ones here, the integration, you typically need more information to be able to figure out what that c value actually was. So what that means, so typically displacement, the function is called st. So the s stands for the displacement, the s, and that's normally a function of time, which is where that t is, and that's normally in seconds. The velocity, we said that was the derivative of that, so that's going to be s dash t, and sometimes you can refer that to as the velocity of t. And finally, the last one, again, if we differentiate again, well, that would be the second derivative of t, which would be the derivative of the velocity, the velocity. Sorry about that, struggling with my words about the velocity. And finally, if you do that, that will give you the acceleration with respect to time. And just to note, we've already chatted about the units. St would be in terms of meters. The velocity would be in terms of meters per second. And the acceleration would be in terms of meters per seconds squared. So that was a quick summary of very generally what kinematics is. We've also gone through the ordering of displacement, velocity, and acceleration. We've linked how all three of those are linked with our calculus methods, differentiation and integration. And finally, we wrapped up with the notation, ST, VT, and AT. And we then wrapped up with a comparison of what units are attached to which function. So hopefully you found this short video introducing kinematics useful. If you haven't, please, you must take notes. Definitely understand this magic diagram right at the top there. And once you've done that, watch the next video. We'll explain how we can actually use these concepts to solve problems. Thanks for listening, guys.